Why, hello there, little baby. Are you familiar with Newtonian physics? No? Someone's being a little left behind then. Don't worry. I will teach it to you. And by I mean the book. The book will teach it to you. Reading is the greatest thing you could possibly do for yourself. That is the greatest form of self-care for you. Guarding your mind and allow things to bloom. Long term, you never know when knowledge will become handy. It's kind of like the series of unfortunate events. If Klaus Baudelaire didn't read as much as he did, then he wouldn't know how to get himself out of so many jams that were set up by callous bohemian adults, preying on those that are the most vulnerable and innocent. So, let us begin with our lesson today. This is a ball. So this is a ball. The ball feels the force of gravity. So the ball, it feels the force of gravity. It goes downwards because there's a force up here that is pushing it down. We cannot see gravity. It is the force that keeps us on the ground. So if you were to go out into outer space, you would float around, kind of like a ghost, drifting forever and ever. In fact, that's what's so scary, is that if you end up being lost in space, there really is no way for you to swim back to something that can give you a sense of solid base. You're just sort of forever drifting against your will. So, if we didn't have gravity pulling us downward, we would drift away from the earth and sort of float away like a helium balloon into the skies. The force of gravity pulls the ball down. So the force of gravity is pulling the ball down. In fact, the force of gravity isn't up here, it's down here, it's the mass. Whatever your mass is the strength of your gravity. I'm sure we will cover this later on in the book. This ball is on the ground. So it's on the ground. The ball is on the ground. Completely disregard what I said about gravity being up here. It is not up here. It still feels the force of gravity. So it's still feeling this force, this attraction, this magnetism to gravity. It keeps feeling it. It feels it deeply. But it also feels the force of the ground. So gravity is bringing it down, and then the ground is sort of repelling against it. The force of the ground equals the force of the gravity. So, however, we'll cover this next, but the force of the ground equals the force of the gravity. So, whatever the ground is, however big the ground is, that equals the force of the gravity. And the force of the gravity is equal to however big the ground is. So if it's a big ground, it's going to attract it even more. If it's a small ground, it's going to have less of a pull. The net force on the ball is 0. So right now, the net force on the ball is 0. It just sort of lingers. It's just there, minding its own business. It does not change its motion. So it's not changing motion. It's staying still, completely unbothered, completely untouched, unmoved. This is a ball. This ball has a net force. So there's the ball and it has a net force. What is a net force? It does change its motion. It accelerates, so it starts to move. The ball has motion and it starts to move. This ball has mass. So this ball, it has mass. However big it is what its mass is. It's massive, mass. If something is huge, you say it's massive because it has a lot of mass. This ball has more mass, so this is an even bigger ball. But this ball has less mass, so this is a tiny ball. This big ball has more mass because it is bigger. It's massive. This ball has less mass because it's smaller, so it's the opposite of massive. It's just small. More mass, more force. So the more the mass, the stronger the pull. Because it's bigger, so it's going to attract more. Less mass, less force. So it's a small, tiny little ball, and it's not going to have that strong of a pull because it's small. So because it's so tiny, it doesn't have the strength to pull at something to attract it. Meanwhile, the bigger mass does have the strength to pull what it wants. The force of the ground always equals the force of the gravity. So that's the net force. So we have the force of gravity pulling it towards this force of the ground. So the ground is bigger, so it's always going to equal the force of the gravity. So the bigger it is, the stronger the gravity. The smaller it is, the weaker the gravity. This is Sir Isaac Newton. That's Isaac Newton right there. He wrote 3 laws of motion. 3 laws of motion, Isaac Newton. He was an alchemist. He was super obsessed with alchemy. It's always interesting to delve into the forgotten arts and see how much value and rich depth is in it, and then acknowledge or recognize, understand how it is that our modern secular sciences are nothing more than plasticine, fake, superficial interpretations, very flat and devoid of truth interpretations of rich experiments, understanding and arts. It in itself becomes a false education meant to prime people to confide in that which they've been told is rational, when in reality, how rational can their understanding be if it constantly changes and contradicts itself every 2 seconds? Meanwhile, with richer depth in alchemy or in other sort of practices, anything that has depth to it, history to it, anything that reveals a more ancient and archaic knowledge, anything that can at least give you insight into how the human psyche reflected in civilization has worked, that will hold the truth to patterns which those who rise above the ranks of the most common, arrogant-minded person chooses in their arrogance to ignore. How's baby feeling? Let's continue. When this apple falls from the tree, it does not float away. So if the apple falls from the tree, it's not going to float away. It is going to fall. That is how Isaac Newton discovered gravity, was because supposedly an apple fell on his head. This apple feels the force of gravity. It drops down to the earth and gets attracted to the mass of the earth because the earth is so massive that it's keeping us all tightly secured to the ground. Sir Isaac Newton feels the force of the apple. So Isaac Newton felt that force of gravity. That's how you measure gravity, is how big the mass is. You then feel the weight or the impact, And then that basically kind of gives you an indication as to what's going on in this motion, basically. That's why if it were bigger, it would have killed him, because the force of gravity would have been way too strong for him, and it would have made a larger impact. Now you know Newtonian physics. Physics is basically the measurement of motion. Once you start to understand the image, once you start to understand the description of what it's trying to explain, things become a little more intuitive. Things start to become a little more clear. But if it's only being taught in a very, once again, plastic, fake, superficial, arrogant, egoistic, and disconnected way, then it's going to become very, very, very difficult to understand what is being discussed, because there is no personal connection nor a concept attached to what you're learning, nor the purpose or motivation behind why you should learn it. First law. Let's cover Newton's 3 laws of motion. Newton's first law of motion. If an object has 0 net force, it does not change its motion. Second law. Newton's second law of motion. The net force is equal to mass times acceleration. Let's recap that. Newton's second law of motion. The net force is equal to mass times acceleration. So net force equals how big it is times how quickly it's moving. And number 3, Newton's third law of motion. For every force, there is an equal force in the opposite direction. So in the same way that there's gravity pulling you down, there's also a relationship between you and the ground. So there's going to be always, let me see, how can I explain this? Of course, there's an equal force in the opposite direction. Yeah. There's always going to be this sort of friction where it's like the ground is going to be attracting you, but then your own force as it hits will also spin you out in as hard of a direction as you were attracted to it, basically. I apologize if that wasn't very clear. I perhaps might admit that my grasp on that one might not be so secure. Nonetheless, I hope baby learned a lot today, and I hope that baby gets to rest on their newfound education. Anyways, I'm gonna go find you a bottle of pistachio.